So all the materials will be uploaded on E3 before each week. And the lecturing hours will be 10 to 12 each Wednesday. And then we will have an online course on Friday. And for Friday, it is about paper presentations. So for you guys have already taken the memory storage systems, we will have the same style. Just like for each team, you will do the paper presentations. And then if you are not the teams that need to do the present that week, then you don't really need to join with us. Okay, so this will be the link, the WebEx link you can use to join. One moment, there's a lot to join us. Okay, so you can use this link to join us each week. And then for the prerequisites, actually there's no really prerequisites you need to have. Like we welcome beginners to learn together. For each of the components for the operating system, we will start from the very beginning, and then we will move on gradually to the deepest part. And if you really want to learn beforehand, or you want to know what we are going to learn each week, you can go on the YouTube. We have uploaded the recording on YouTube. Like each week, we already uploaded on it. Okay, so you can access this link. And all right, so the course will be hybrid. So we will do the streaming and recording. So streaming will be on WebEx, and recording each week we will do the recording, and I will upload the recording video on E3 each week. Okay, and then this is our syllabus. So today we will do the course introduction, so it will be super fast, and then the next week we'll do a quick summary and a recap about the operating systems, like the big picture of why we need the operating systems, and then what is the relationship between operating system and computer architectures, and how Linux kernel works, because this course will all about Linux kernel, and then like some recap about how like CPU processor and then memory management, those kind of stuff. So we will use 1 week to recall those kind of stuff. And then we will go into the details of each part, like processing and CPU scheduling. It will take about like 3 weeks. So we'll talk about the processing threads, CPU scheduling on Linux, and then system calls. And there will be one hands-on around like September 24. It is about the system call part. And one special thing to let you know is, because on October 1st, I need to attend a conference in Taipei in the afternoon. So we'll only do 1 hour course, and there's another 1 hour will be the next day on Thursday, like October 2. And that course will be, I will invite the professors from UH to give you guys a talk about embedded system stuff. Okay, then we will have a holiday on October 8th. Following on, we'll move on to memory management. So there are 2 parts of memory management we're going to learn. The first is about the physical memory management, like when you are using DRAM as a memory, and how Linux kernel partition those kind of different resources. And then we will move on to the virtual memory management, including the patching stuff you already learned in the undergraduate. And then there will be another hands-on, probably it is about the CPU scheduling stuff. And then our midterm will be on October 29. Okay. After the midterm, we will talk about some advanced research topic about the like from x86 to RISC-V, and then some memory extension topics on November 5. And then after that, it is all about the I/O's part. So we will talk about the I/O device from the bottom, and then we will move on to the block layer and the drivers, and then the file systems. So it will be 2 weeks for the file system. And then on December 3, because I'm going to attend a conference internationally, so we have no class at a week. And then our final will be on December 17th. So this is the rough schedule like for this semester. Okay. So the grading part is 30% for midterm, 30% for final, and there are all paper stuff. And then 10% for the paper presentations for each team. Okay. And then 30% for the hands-on. So we will have 3 homeworks, and each of them will get 10%. And we slightly changed because like this course already have like 3 years before now. So we slightly changed the hands-on, we added some like requirements, and then we slightly tweaked about what you're going to do for the hands-on. Okay. So this time it will be a little bit different from the past 3 years. And then the same, we will have a 6% of the class participations. So notably, we will have no like participation score. So you don't really need to come in person or online if you don't feel good, and then or if you like you have some things you need to do, you don't really need to join with us because we have the recording video, so you can always check on the E3 about the recording videos. And if you are going to get the class participation score, it is you can ask the questions. So one question is 2 points, maximum is 6 points, like 6% here. So you can ask in person here, or you can ask online on the WebEx. So more details will let you know next week about how to get this kind of 6% of the class participation score. Okay, question. All right, so for the paper presentations, like for each team, you will have 6 to 8 minutes. So don't go over 8 minutes because you know this semester we have around 300 students here. So if you go over time, then you will probably delay the full schedule. And for each team, it should be 3 members for each teams because you have 300. So we need to have like around like 100 groups here. So please do not do fewer. Okay. And the paper you can get from those kind of conference venue from Usenix, OCI to Eurosys, those are all recommended. And papers should be published after 2020. So for those before 2020, you will not be counted. Okay, this is very important because last year, some groups that get the papers before the time, then we will take some points about their score. Okay. And then for the conference, if you can find any interesting papers on those kind of conference venue, you can also find the conference by using this link, and you should get the A rank on this link. And then the package should be more than 10 pages in 2 column formats. So if you can find this other conference those, for example, if you are interested in database and like Sigmod, those kind of conference I didn't really list on it, you can still you can email me to ask about if it is possible, or you can follow this kind of rules to get the papers on those conference. Okay, so papers should be related to operating system software, or computer architecture. Okay, because this course is a computer course. So for the grading parts, total you can get 10 points for the maximum, and then there are 3 criteria for reviewing your presentations. The first is about easy to follow. We highly suggest you to use more figures as much as possible because like there's only 6 to 8 minutes. So if you have too many tabs on it, so I think it will be hard to follow. So more figures will be easier for grasping the information. The second will be like we would highlight the motivation part because you only have 6 to 8 minutes. So I think you don't have too much of details to talk about to detail the algorithm or data structures. So motivation will be more important for our criteria. Methodology, what you are going to do is going to give us an insight about what their methodology is about, and then a big picture about what their methodology, and then what's the relationship between the methodology and the motivation, and that will be enough. So you don't really need to really give us the evaluation because we only have like at most like 8 minutes. So you can remove all the evaluation if you want. Okay. So I think we'll give you more details next week about how we are going to grade the paper presentations. Okay. So there are some important things that you know. So actually you can find some slides on the internet. For example, for using series conference, there are already slides there. So please do not directly use the PowerPoint or PDF online. So please remake it by yourself. Otherwise, we will take out some scores on your presentations. Okay. So English and Chinese are acceptable, and we will know there's no differentiate on the scores. Like if you use Chinese, we will not take out any points on it. So don't worry about it. Okay. So the key thing is please use the language you are more familiar with. Like if you don't feel comfortable on using English, then you can just use Chinese. Otherwise, it will affect the presentations. Okay. So that is about the paper presentations. And then if your team is hard to do the presentation on in the morning of Friday, then you can send me an email. We can reschedule some time slots other than the Friday. Okay. So we will announce the spreadsheet on E3 around tomorrow at PM, sometimes around this. So just put your name of the preferred time slots and then the papers. Okay. The thing is, you don't really need to give us the paper name you are going to present at this moment. You should give us the paper name like 2 weeks before your presentation. Okay. So you can just register the time slots like you prefer on the spreadsheet first. Okay, so this is about the paper presentations. Questions? All right. So textbooks, actually, most of our materials are from the Linux kernel development, the 3rd edition by Robert Lerf. And then we'll get some other things from the rest of the 2 book series. So if you are interested, you can just get books and then to read it. And then some of our materials also are from the conference venues, lots of it. So just for reference. Okay, and there are some code in our slides, and those code usually you can find the code on the boolean.com for Linux. Actually, you can get any version of the Linux and the source codes from this link. Okay. So one thing to emphasize, because for the past few years, people keep asking about when we talk about operating system other than Linux. Actually, no, we will only focus on Linux. And yeah, so if you are interested in other operating systems, then you might need to pick other course. Okay, so this course, Linux only. So let me quickly go through some takeaways about what you will learn. So first of all, for the first few weeks, we will talk about the operating system and process. So after the first few weeks, I think you can answer the following few questions. The first one is, why do we need an operating system? And the second one is, what is Linux kernel and how our computer runs Linux kernel? Okay. And then what is a process and a thread in Linux? So how to create them and what is the characteristic between each of them? Then how Linux schedules process. So I think they will be a little bit different from the things you learned from undergraduate. Usually undergraduate will only give you some overview about the general operating system, what would it look like. But this time we'll let you know more details about the history of the Linux scheduler from 01 to the widely used scheduler in Linux. Okay. And then how does context switch run in the kernel? How expensive it is? We'll have a deep dive into the context switch, and then let you know about actually context switch is quite expensive when system is going to run it. Then why we need system calls and interrupts? How do they work? So we will have a hands-on to that you try about how to create your own system calls on Linux and what will it look like. Okay, so yeah, what challenge do current OS best, those kind of stuff. Then after that, we'll move on to the memory topic. So for memory topic, there are also a few questions. I think you can do it after learning about these lectures. Is how kernel manages and allocates VRAM, and why system needs virtual memory. So what is paging? How does it work? How a CPU works patch table. So it is quite important. Actually, for the memory part, it will be highly related to CPU itself. For example, when we learn about patch table working in undergraduate, most of cases we don't really learn about what kind of scenario you would work the patch table. and then how CPU really works the patch table. So, because we only focus on Linux, so this time we'll have more details to explore about how CPU really works the patch table and what does the hardware look like, and how expensive it is. Also, like if there are patch flows, then how CPU handles the patch flow, and how does memory management units, the MMU works like. So for the I/O part, actually, this is the typical figures you can find on the internet about the Linux I/O stack diagrams. So I mean, this is the earlier version for like 2.4 or 2.6, something like that. And later Linux version, this diagram will become quite complex, but actually the key things, they are all the same. So we will talk about from the bottom, like the device part, we will talk about SSD, hard disk drive, and SMR. Okay, and then we will talk about why system needs device driver, why do we need block I/O layers, and also we'll introduce about the file system. We'll talk about the log structure file system, give you a more concrete example about how file system works like. And why do we need a virtual file system? What is patch cache and how does it work? So actually, if you guys already taken the memory storage system, this part will be highly overlapping with that course. Okay. So for the rest of them is the application. So if we have sometimes after those topics, we will talk about some applications labeled integration with operating system. So we will talk about the graph systems, the key value database, and then how super fast storage device. So usually people call them ultra low latency storage, SSD, and how can those kind of very fast storage device affect the operating system designs, and then how the OS changes from moving from x86 to RISC-V. Okay, so I think those are all things that you can learn from this course. Okay, so sorry, I think this should be Wednesday. Let me change it. So I think this is what I'm going to let you know today. So any questions for the overview part? All right, so if there's a question, then see you guys next Wednesday. So for those guys who are going to get that registration, please stay here.
好，我先说一下规则，因为目前大概有50个名额，所以我们等一下先看一下现场有多少同学要加选。然后因为系上有不断强调资工系的学生需要先选，所以等一下优先顺序会是资工系的会是捡优先的。然后其他的如果我们还有名额的话，我们就直接现场抽签这样子。对，那基本上我的经验，基本上虽然我们说50个名额，但是最后通常是可以收到第100个人这样，因为一定会有蛮多人最后会退选的，对，所以我们先要加选这样。
那我算一下，还是先把它。
然后我应该要让他们直接线上登记。对，不用扫。那我